Hi guys, good morning. Welcome back to the new video. So quickly, a blunder happened with me. I forgot that my cell was not working. Started recording, recorded the halfway down, then I realized okay, it's not working. So started it again. But before that, if you guys don't know, it's actually I'll if you have to actually find the intuition of this problem and do everything from scratch, please skip the next 15-20 seconds. But for those who know, who have solved yesterday's and before that a day before yesterday problem, then for sure you guys know that it's a sliding window problem. It's very standard. I have given all the kind of sliding windows, same format problems above also, so for you to practice the sliding window problems very well. And if you have not solved, you can also solve our ESA 169 series, in which you have the sliding windows proper, all from easy, medium to hard problems. And the problem which you're going to see, this thing, maximize the confusion of an exam, it's the same as that of the longest repeating character of character replacement. So without further ado, let's start with the problem statement itself. It's very easy. It's just that saying, okay, we have a test in which we have n true and false questions. Now we have to maximize the number of consecutive questions with the same answer, which means either it can be a same, which means either it can be a true or it can be a false itself. Now what is a answer key? Answer key of I is the original answer, which means it can be originally it is true or a false. Now what I am given an integer k, which is the maximum number of times I can perform some operation. What's the operation like? Operation is to change the answer key of an operation of any question from t to f or f to t. Vice versa, I can change the answer key for any question to true, any question to true or false, which means if it is a false, I can change it to true, or if it is a true, I can change it to a false. Now what I have to do is return the maximum number of consecutive t's or f's in the answer key. So firstly, in this line itself, the intuition is hidden. Firstly, if you have read this and I'm saying, okay, in this line intuition is hidden, in this line itself, or let's say in these four words, the intuition is hidden. So please, if you have still not found the intuition, just read this line again and find, okay, what Aryan is about to say or is trying to say. Cool. Let's quickly jump to the example itself to see what this true, false, true means like. So we have this answer key TTFF. I can change at max two of them. Either I can change the T to S or I can change the F to T's. Then I'll simply say, okay, just changing the T's to F to T's, it would be the best optimal for me to get all the four as trues. Now here I can change just one. So firstly, I tried to change my F to T's. If I change this F to T, so consecutive T's possible are two here, but if I change a T to F, then possible F's are here 3. So the maximum is 3, the answer is 3. Here in this case, we have a TT, F, TT, F, TT, and then TTTTT, and then I can change at max one of them. So I try changing one of the F's to T, I get 5 as the consecutive T's, and that's my maximum answer. You can try for everyone, which means try to replace this particular T, you still get a 5. Then you try to replace an T's with F. Maybe you replace this, so you will get maximum of 2. You will try to replace this with F, you will get a maximum of 2. So maximum out of replacing either T's with F or F with T's, you will get a maximum of 5. Now constraints are pretty 5 into 24, which says, okay, you can try at max n or n log n. So let's see. Back to what we are thinking about, maximum number of consecutive T's or F. If I just go back to forget this maximum number and forget this replacement part, the operation part. Just if I ask you, hey, please find the consecutive number of T's or consecutive number of F's, how would have you found out that? Simply going back to a standard example which we have. Okay, if we have some consecutive zeros and ones, so to find the consecutive number of zeros, okay, I have the consecutive number of zeros as 3, 2, 4, and then 1. What we use? We simply use a sliding window. Either we can just go and do a sub-array kind of stuff and go in n square. But we have seen, okay, to find the consecutive groups, we can use simply a sliding window. And still, if you have not seen this, no worries at all. We will actually see, dry run the entire stuff, that how this consecutive thingy work. Now, firstly, if you know, then again go and try. Now you have known that, okay, sliding window kind of stuff will work on this. Just a slight modification on the sliding window, because see, it's just that, okay, you have to find your T group But now you have a liberty that, okay, you can extend this group considering the fact because you can replace a particular f with a t. So a slight modification is now I can change at max k characters to other character, which means if it's a t, I can change to f to t. So now I can extend my window because I know I have some k left to actually extend it, to actually replace my other characters. So what I will do is earlier what was happening is if I had to find the consecutive t's, I was just starting my left from here and right went up till this particular t itself, because the next coming character is f and I cannot go on f. But here I have a liberty, I have my k as 2, which means two f's which occurs, I can think of them as a true itself, or I can change them as true. So here one f came in, I'll say okay, now I still have a liberty of using one f, so I'll still go on forward. Okay, now my all two f's are exhausted, but still I can still go on forward, right? Because it's a t, I can still go on forward. But here next, as f was about to come, three f's was about to get exhausted, but no, I cannot. So I'll just stop here. So now earlier when I was not given any k, my window size was this 3. Now my window size is this big, which is 1 2 3 4 5 6 7 8. That is how you can solve this pattern problem. Okay, because you can extend your window size because of this k factor which you have. Let's see how you will do it. And see, firstly, that okay, you can convert. Here you saw I converted my f to a t, and then I was doing it. And same I can do vice versa for t to a f, which means I can convert my t to a f also, right? So as to get the f window size, here I'm getting a t window size, I can get the f window size also. So please, when you will try this sliding window, try both, convert t to f and also convert f to t and find, okay, what is the maximum value you can get. Now coming back to how the sliding window thingy work, for those who know, just try by yourself. For those who don't, let's try run it, that how it works. Firstly, sliding window, which means window. For a window, you need to have a left and a right. Now, right as in you are moving, because you know that, okay, you have to complete that in a pass. Now, when I say in a pass, okay, you will always keep on moving forward. You will not go back and forth. You'll always keep on moving forward. So as I'm going on to every character, okay, I will say, okay, every character I land onto is my right. And then I will have a left pointer. So basically I have a left, I have a right, and with this left and right I can know, okay, what is my window, and with this I can know my window size also, because right minus left plus 1 is the window size. Now I'll start my I with here standard, I will keep on moving forward, as simple as that. And accordingly, when I cannot move I as forward because of some condition, I will try to move my L forward. So basically how a sliding window works is your I moves forward, and then when I cannot move forward because of my L left, because your left started from here itself, now I came in here, now I cannot move forward because of the left. Now if I cannot move forward, then what we will do is we can move your left itself, we can move our left. So now I can also move forward. That is how a sliding window works, which means I moving forward, stuck. Now L will forward, okay, now I can move. Now stuck, still stuck, I stuck, then okay, L will move, then okay, now I can move. So it is how a sliding window works. Now simple as that, I have my I have my left. You know that, okay, my condition is primarily I can utilize this k as 2. My count now, what I in this particular point, I am trying to change my f's to a t, which means I will try to know the count of my f being changed so far. Cool. So far I have not encountered any f. So basically the count is 0. And also parallelly I will maintain the length. Currently, what is the length I have right now? Because I need to also update my maximum length, which is the answer, which is by the maximum of answer comma length. Because ultimately I'm concerned about the maximum length, which I will keep on storing in the answer variable itself. Now coming back to dry run, I will move my I because I can move because my count is 0, and it can at max go to 2 or 3. If it goes to 3, then I have to stop. Okay, I can't go to 3. Now count is 0. Cool. Here you will see again the count is 0 but the length is 2. Here you will see the count is 0 but the length is 3. Here you will see as soon as the f is encountered, oh okay, no, count has become 1. But still that 1 is less than equal to 2, so I can still go on. Cool. Now I also keep on updating my answer with the maximum answer, which means at every point of time my answer will be nothing but answer is equals to maximum of answer comma this length. Keep record, keep on this mind, right? Point. Cool. Now I got the next T. Cool. Count is still 1, but the length is 5. Next F, count is 2, but length is still 6. Should you stop with this count? Because count has reached 2 and the maximum limit was 2. You should not stop it. Why? Maybe because the next thing is a T. So you should stop when you have actually exceeded your limit. Because still if it is T, you can still go on. With this count as 2, you can still go on. So you have to stop when your count exceeds your K and not at K, because you still can find a T. Now, cool, I find a T, my length has been increasing. Cool, I find again a T, length is again increasing. Now, here up till so far, you are keep on tracking your maximum answer itself. Now, as soon as another F came in, count has 3. It has exceeded my limit of K. So please, I cannot update my answer yet because my count is 3. So please firstly bring count less than equal to my K. For that, I know I cannot move forward. I cannot move forward my I. So now I have to move my L. How L will move? Simply, it will just keep on moving until my count is less than equal to K. So here it will just still move. See, my answer will never update until my count has become less than equal to my K. So answer only update when my count is less than equal to K. So here the length will keep, but yeah, still my count is 3. Okay, still the count is 3. L pointer moved forward. Still the count is 3. Now L pointer move forward. Now the count has become 2. Get the length and update the answer. Cool. Now I'll again move forward. Now my L is here. I can now move forward my I. Now my I will move forward. Okay. Oh, again it is stuck. Now again I'll try to move my F. Okay, F will move here. No worries. It will still count as 3. F will move here. Now the count has become 2. Okay, the count has become 2. Now I can find, okay, what is the length like, and I can update my answer. Now again, I have this particular, okay, it is actually here itself. I can move it and I can find, okay, what is the answer like. Now simply, okay, here the L should have been here, and so the count is actually a 2, but the length is actually a 4. So you will update your answer with the maximum length itself. No worries. Now again, for sure you can move your I itself. You moved your I itself. Now again, as you moved your I itself, you know that, okay, you have to bring in the limit because count has become 3. Please bring in the limit. My L moved. Now again L has to move. Now L has become 3. Sorry, L has become 2, but count has also become 2. So update your answer. And this is so on how the sliding window will keep on moving. Move your I. If it is stuck, if it can't move your L. Then again move your I, move your L. Move your I, move your L. That is how sliding window works. And as soon as your count is, if it is less than equal to, please update your answer. If it is not, then please firstly make it less than equal to my K. And it is the same stuff which I have to repeat for converting my T to F also. Here you saw I'm converting my F to T's in the same step, exactly same loop I have to repeat for converting my T to F's. Let's get the code. It's very simple, very simple. I will have a left, I will have an answer, I will have a count. You know what's the left? Left is nothing but my left pointer. Answer is nothing but the maximum answer. And count is, okay, for count of F, for count of T, and so on, which we have seen so far because you are maintaining a count, right? Okay, what is the count of F's got so far? So now in this particular for loop, as I said, I'll have to repeat the same step. So you will see that, okay, both these loops are exactly the same. Just a difference of T. And you will see here it is a F. That's it. That's the only difference which you will see in these two loops. So either you can make a function also above and then use and then call with the modification of this character F or a T, or you can also make two functions and to just solve it quickly. It's just modularizing the code itself. Now, as we saw in this, I will just try to change. Okay, I will just get the maximum substring of T, okay, which contains at most KFs. So with this, I can get the maximum of my answer. With this, okay, a substring of T I am getting. Now how? Simply getting, okay, if I have IF, please increase the count. But as soon as my count becomes more than K, I have to go on shifting my left pointer. I have to go on shifting, increasing my left pointer until my count becomes less than or equal to K. So if it is becoming, then I can for sure update my answer. You know, I'm updating my answer only when I'm making sure that my count is actually less than equal to k. If it is more than equal to k, then please firstly increase the left and bring it such that it is less than, count is less than equal to k. And by this I can update my answer with nothing but the window size, which is I minus left plus 1, which is right minus left plus 1, and with the existing answer which I have. And the same step I'm going to repeat. I'll simply do like reverse it back, which means bring my count and left back to 0, and then again try to go on with my I itself, and then we'll try to check. Okay, if now I will just try to see, okay, if it's a t, increase your count, because now you have the task of finding the maximum substring length of f's. For that you can convert your t to f at most k times, and thus I will just try to convert. If I am trying to convert and this count becomes more than k, please shift it back to less than equal to k and then update your answer. And this, by this I will get my maximum answer. So you know that, okay, you just have these two calls, these two for loops. Also you can modularize this by placing this in a one function call and just passing a argument as a character f or a t, and by this you can also solve it. So the time is nothing but O of n. It is actually O of 2 into n, because you are doing here also a sliding window and here also a sliding window. If you want to do in a one pass, it is also possible. It is also possible to do in a one pass, because here you will see you're doing a two pass, firstly for a t and then for a f. If you want to do in a one pass, simply nothing but you have to take care of 2 and f simultaneously. By this, either you can use a if else condition, which means use two characters or two variables as for true and false to keep track, okay, what's a true and false length, and also for the existing true and false you have found so far. Or you can use simply an array of characters if you don't want to use an if else condition. That array of characters will make sure, okay, if you're landing a character, if it's a true, you can just point it back, okay, and know the count of your true and false. It's pretty easy, and we have seen this kind of modification. It's just nothing but doing a simple code modification that, okay, you are handling both the cases, because it's just two cases at max, right? It's a true or a false. So you just handle that true and false cases either in an if else condition or by using simply an array of characters, and that array of characters is nothing but maximum size of 26. So that itself is more than sufficient. And space is nothing but O of 1, but if you use this, then it will be space of O of 26. Or if you can use this also, that also will work for sure. Cool. That's all for this video. I hope that you guys like it. Bye bye.